right, so let's talk about section 6.6. This is the last section in chapter 6. And as always, you probably should have your unit circle handy. So over the course of this section, we're going to learn how to use the double angle formulas to find exact values. We're going to use double angle formulas to establish identities. We love establishing an identity. And we're going to use the half angle formulas to find exact values. So let's first introduce the double angle formulas. So the double angle formulas are sine of 2 theta. Maybe I shouldn't write in blue so you can actually see what's going on. So, there we go. Sine of 2 theta equals 2 sine theta cosine theta. Cosine of 2 theta can be defined in 3 different ways, which is pretty neat, I think. So I can do cosine squared theta minus sine squared theta, or I could do 1 minus 2 sine squared theta, or I could do 2 cosine theta minus 1. So this is the one that I honestly end up using the most for cosine, but all of them would help you solve the equations equally. I'm going to make sure we work through a few examples so we can get the hang of using these double angle formulas. So if sine of theta is 5 over 6, and my theta is between pi over 2 and pi, that means I'm in quadrant 2, right? So my cosine is negative. And if I double this, I'm probably going to end up being in quadrant 3 where my sine is negative, right? Because now we're trying to find 2 times our theta. So whereas before I had from pi over 2 to theta to pi, now I'm going to be going from pi to 2 pi, and that's where my sine is negative. So this answer is going to be negative because our theta, because 2 theta is in quadrants 3 or 4. So we always need to know what quadrant we're in. Now, sine of 2 theta is 2 sine theta cosine theta. Now, I know sine of theta, but I don't know cosine theta. So we're going to find that by solving our equation for a circle, remembering that sine of theta is y over r. So if I have x squared plus 5 squared equals 6 squared, that gives me x squared plus 25 equals 36. So x squared is going to equal 11. So x equals square root of 11, which is negative, right? Because cosine's negative in between pi over 2 and pi. So now I know that cosine of theta is negative square root of 11 over 6. And my sine is 5 over 6. So we can solve this. I now have 2 sine of theta, which is 5 over 6, times cosine theta, which is negative square root of 11 over 6. So I get for my final answer negative 10 square root of 11 over 36, which I can simplify by pulling out a factor of 2. So I get negative 5 square root of 11 over 18. This is our final answer. Let's work through another example. What if I have cosine of 2 theta? Well, we already figured out that if I have sine of theta, that's 5, 6. Our cosine theta was negative square root of 11 over 6. Remember, we figured that out right here. Here's my cosine theta. So now I can solve for cosine of 2 theta using any of the 3 cosine of 2 theta formulas I have. I'm going to use 1 minus 2 sine squared theta, because for this one you really only need to know the sine of theta. So I have cosine of 2 theta equals 1 minus 2 times 5, 6 squared. So I have 1 minus 2 times 25, 36, which is 1 minus 50, 36. 1 minus 25 eighteenths, so I have negative 7 eighteenths. And remember that because we're in 2 theta, our theta is now in quadrant, so 2 theta, right, is now in quadrants 3 or 4, where my cosine would be negative, at least in 3. So we're in quadrant 3. Next, let's develop a formula for tan of 2 theta in terms of tan of theta. This doesn't use any new information to us, right? Remember from section 6.5 that if I have tan of alpha plus beta, that equals tan of alpha plus tan of beta over 1 minus tan alpha tan beta. And if I have tan of alpha minus beta, that equals tan alpha minus, it's supposed to be a minus, minus tan beta over 1 plus tan alpha tan beta. I don't know if you could hear that, but I'm recording at home and my next door neighbor has chickens. So sorry if they're distracting. So what we're going to do is we're going to rewrite tan of 2 theta as tan of theta plus theta. So that means theta is both my alpha and my beta. So I'm going to go ahead and substitute in tan of theta plus tan of theta over 1 minus tan of theta, tan of theta. And we're going to go ahead and combine like terms. So tan of theta plus tan of theta gives me 2 tan theta. And 1 minus tan of theta, this theta times tan of theta is 1 minus tan squared theta. So there we've developed a formula for tan of 2 theta using what we already knew about the sum and difference for tangent.